Okay, our very first course is Introduction to Databases and SQL. So we're going to be using a database system or a database server called Postgres or PostgreSQL for this course. But before that, we're going to go over the basic concepts of a database and what databases are and how they are used and what kind of purposes they serve and so on and so on. So before I go ahead, discuss some of the concepts, what do you think is a database? So it doesn't have to be accurate dictionary definition of this term, but when you hear of the word database, what do you think of? What comes to mind? What is a database to you?
I think it's a data collection of data stored in a well-organized manner.
Okay, good definition, but not 100% accurate. Let's say based on your definition, I collect data and store it very organized in a very organized way. And it is in in my shelf, let's say. It's a collection of papers. Is that a database? It's a data. It's a collection of data and it's stored in very organized manner. Is that a database? It meets your definition, but does it count as a database?
As long as it has a variety of data and then kind of segregated into their own segments and stored.
Yeah. Filing cabinet, for example, when we go to ቀበሌ ኢትዮጵያ filing system አላቸው filing cabinet አላቸው. They organized everything in different categories in envelopes, folders, and so on. It's a whole collection of variety of data organized into different categories, groups. So that
Well,
fits your definition. So can we say that they have a database system?
no, that is not because it's not electronically stored. That you should have
Okay.
to manually
Okay.
manipulate.
Okay. So the second thing that a database should uh, fulfill characteristics is electronic. So it has to be electronically stored. That's a very big change from your original definition. If it is electronically stored, then that's much closer to what a database actually is. So
That can be queried and retrieved.
perfect. That's very good.
And also row and column based.
Okay, that's very true, but that's only one kind of database system. So for this course, we're going to be focusing only on those kind of databases in a row and column formats. But there are so many data types, data sets that are not stored in a row or column or tabular form. Actually, most of the data in the world right now is stored in a format other than a tabular format. So that's why we have the concept of big data, because we no longer have every data in the form of table nowadays. So one definition we can come up from all these different definitions you gave me is one is a collection of data, of course, and the collection has to be stored electronically. That's a big thing because there are different cases we collect data and organize it and store it like in a filing cabinet. But that doesn't count as a database. It has to be electronic. And there are also other electronic collection of data. For example, if we store our files in a folder, a collection of word processor files, Excel, CSV files, PDF, and so on, in very organized manner, does that count as a database? I know Kafalo mentioned something very important that would make something qualify as a database on top of being electronic and a collection of data. But in this example, if we have a folder full of organized files, is that a database? And why not if you think it's not a database?
It's not if it's not easily accessible and retrievable, and then that
Yeah,
cannot be.
it's can be easily accessible, it's retrievable, but the key is, you're right, it has to have a database, needs to have its own language to automatically and programmatically. This is a keyword, programmatically, with a code or a program to retrieve the data, retrieve, process, and manage the data. So database has to be a system where we can electronically store data in a very organized manner, and we can manage that data, store it, process it using a programming language. That's why Excel is not a database. We can store however data we want to, except of course it has limitations in terms of capacity, but any database system with some level of capacity, even if it's limited, can be a database. It's not about the capacity, the size. It's about its functionalities. So Excel doesn't have those functionalities, such as we can not programmatically access the data. We can access the data manually. We can open the file and do analysis and so on, but we cannot write a language, a programming language, a code to access the data programmatically, process it, and manage it. So on top of everything we've said, the data has to be retrieved, managed, and processed programmatically with some sort of programming language for something to be called a database system. So collection of data, organized, electronically stored, and managed, retrieved, and processed using a programming language. That's the database. So we can do all sorts of different tasks on top of our different database systems. They enable us to store data. So most people's understanding of database is that it's just a storage of data. That's not. We just discussed and defined a database as something beyond the storage of data. There are so many things so that we can store data in, but that are not databases. And most people's understanding of databases is also they're used for just storage and retrieval purpose. No, they are used for manipulation, processing the data, for securely accessing and managing the data, for validating what's stored in the database, and so all ranges of different capabilities and features that a given simple database has to support database system. There are various types of databases in terms of we can categorize them in terms of their functionalities, in terms of what kind of data they support. ቅድም ዋናው ታቡላር ፎርም ያለኝ በቴብል ኮለም እና ሮው ስቶር የሚያደርጉ ሲስተሞች ናቸው
እኔ
ያለው
ነኝ ያልኩ እኔ ነኝ።
ብርሃኑ። ያ
አዎ።
those databases are called relational databases. So when we categorize databases in terms of what kind of data they support or they are able to store and process, we have relational databases, we have non-relational, relational databases. These are database systems where everything is organized and stored only in a tabular form, columns and rows. And the language that we use to manage and retrieve, process data in this kind of databases is called SQL. So again, some people who have some level of understanding of database systems think SQL is a language of databases. No, strictly speaking, it's the language of only relational databases. Other type of databases, they use their own language. They have their own language. Relational databases use SQL or SQL. Usually the common pronunciation is SQL. I don't know where that came from because this is just SQL, 3 letters, but it's usually the industry standard pronunciation is like this word, like in a movie sequel. For some reason, that's what is the common pronunciation, but you can just call it SQL if you want to. So this is a language that we use to interact with this specific kinds of databases. So these databases are very structured in that everything has to fit into a table. It has to have a column name, table name, specific data type for each column, similar data types. For example, we can look at this one. We can easily store this data. We can easily store this table data into relational database management system. Because one is in a tabular form, two is very structured, meaning every column has a name and every single column has its own data type. You cannot mix data types in a given column. So this is one specific kind of data, which is a text. Full name only stores a text. Phone number is always a number, right? Phone number cannot be a text. You cannot find letters in this, characters. And this is specific kind of data type, timestamp. This stores dates and time. So this very organized, very structured form of data. And this kind of data sets are only stored in what's called relational databases. And the language is called SQL because this stands for, by the way, does anyone know what SQL stands for? SQL?
Structural query language.
Yeah, that's why it's called structured query language because it processes it interacts with structured data. If the data is non-structured or unstructured, this language doesn't work for those kind of data. So this is languages designed specifically for relational database systems where the data is structured and organized. Okay, that's one form of database. And for the rest of this course, in fact, for the rest of this whole program, we have two database related courses. And they're going to be all both based off of this kind of database relational. Why? Two reasons. One is one of the most popular database types. Now its popularity is decreasing because of the things we discussed when we talk about big data, because there are all variety of data right now. Before, back in the days, maybe before social media, pretty much 90% of the data in the world was in this format, table format. But social media came and everything is now in the video form, audio form, and comments, text, very unstructured text. So if Facebook wants to store, it actually does store our comments. they cannot store it in a relational database because it's not structured. It doesn't have any structure. So there's another kind of database systems that are designed for that kind of unstructured data sets. So the structured data set is no longer the dominant, it's still the most popular one, but there are other forms of data sets now in terms of audio, structured data and so on, like I mentioned, that are becoming increasingly very popular. And pretty much most of the data that we're generating as humanity is increasingly becoming more of this kind of data sets other than relational data sets. But still, it is very popular by now. And also, as a data analyst, you're going to most likely 99% of the time going to be working on relational databases because the main data points that businesses use for decision making are stored in this form. For example, finance related data sets, their expenses, incomes, revenue, and so on, customer information, in healthcare as well. Different data sets are stored in tabular form. So pretty much most of the data sets that data analysts, I'm not saying data scientists, that's different area because it's wider in scope than data analysis. But since you are studying to be data analysts or a BI developer, or those of you who are studying to be cloud developers, you may have to know other forms of databases as well. For data analysts and BI developers, this is a dominant one in the market right now. And when you go into your career, when you start your first jobs as a data analyst, you're going to be mostly working with this kind of databases. So that's the main reason we're only going to be learning this kind of databases for the rest of this program. And the other form of databases or kinds of databases is called key value databases or NoSQL databases. These are partly structured, but not as structured as relational databases. I'll give you an example. They are called semi-structured databases, and some data sets are stored in some form of structure, but not everything is structured. For example, let's see how Facebook stores its user information in the back end of their application. So Facebook API. Facebook actually stores our information like this in this kind of format. Okay, let's go back. Let's find something more readable. And this is how they store data in the backend, especially page and user related data sets. So category of this is actually the Facebook Pages API. So API is another concept that we're going to be going over in the upcoming classes. They store this kind of information, data sets about a given page. So with a category, there's an internet company, category list, it has some sort of ID and its own name. And name is name of the page, could be EBC, EVS, or something, a Facebook page. ID, it has a page ID, and so on. There are different data points that they collect and store in this format. So this cannot be stored in a table. It can be stored in a table form, but it wouldn't be very efficient to store it in a table form because we don't know how long the um, name is going to be and what kind of name a page is going to have. It could be a number, it could be a text, it could be anything. And also some of the parts of this data could be anything ranging from one character, one number to up to millions of characters. So since it has some sort of structure, but it's not completely structured, it is stored in a semi-structured database systems, and they're collectively called key value or most commonly NoSQL databases. NoSQL databases are very popular for backend side of most applications. They store their data in this kind of databases. And these two are probably the only two database types you're gonna probably supposed to know in data science or machine learning or data analysis if you hold a senior position, more technical position. And other databases as well. Pretty much all the non-relational databases are called NoSQL, but the most common one is this one. You see NoSQL, 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 but this is just a generic name to signify that all these other types are not relational, not structured. They could be semi-structured, they could be completely unstructured, but the whole point is they're not structured. There are other types, document-oriented, graph, and so on, but we really don't have to go over this kind of databases, and you really don't have to know exactly what how they work and so on. But the whole concept is document-oriented. It's mostly a database type that stored document-based data sets. There's a document storage system called JSON or JavaScript object notation data types. And graph SQL databases are also how social media applications like Facebook store their users' information. That's how Facebook knows your mutual friends and your friends of friends and so on, your mutual interests and so on, because they create networks of nodes of preferences and friend groups and so on, and they one points to the other, and there's a sort of interdependency among different nodes and components of the data. So we really don't have to know these two. Maybe JSON-based databases at some point as a data analyst, or if you become a data scientist, you may have to know. But otherwise, if you are a BI developer in Power BI space or a AWS developer, you really don't have to know this, all the other things. Here, these are the four common database types, database systems. And in terms of this is in terms of what kind of data sets they store. But if we look at databases in terms of how and where they are being built or they're being hosted, we have two main categories, on-prem or on-premises versus cloud database systems. On-prem means we are hosting and running these database systems or basically the softwares of the database server locally or on our own machines. Businesses, for example, they have a huge infrastructure like this, especially back in the days. It's been very common for companies to have this kind of infrastructure. They build this, and these are basically computers without screen, without monitor. And they process and store and manage their database systems within their own local organization within their own premise. So that's where the name came from, on premises. So within themselves, within the businesses themselves. But this approach is very outdated because it has so many downsides. It is very prone to failure, exposed to attacks, even physical uh, attacks, because anyone can enter the server room and create damage here, cause damage to the servers physically. It can be easily infiltrated virtually as well, and so on and so on. It could be damaged by um, natural and man-made disasters, fire, and so on. It's very risky to have an entire business's existence that determines its existence, like such as its database systems, stored in a vulnerable location like this. So comes the cloud. So the cloud was introduced sometime in early 2000s, and companies like Amazon, Microsoft, Google, and so on, because they are very huge multi-billion dollar companies, multi-trillion dollar companies now, they can afford to build infrastructure like this in a very secluded area where no one can easily access it, and where it's safe, and where is a backup in a separate location for the whole entire infrastructure, and so on. They started renting out these spaces to companies. So companies started using those services instead of building this whole thing on premise, on their own, uh, in their own premises. So the other alternative database is cloud. So we have on-premise infrastructure for our database systems, and we have the cloud. So instead of setting up everything like this physically, we can just pay Amazon and create and host our database systems, run our database softwares on the cloud, or meaning on Amazon's server, or if it's Microsoft, on Microsoft Azure's server. It's called Microsoft Azure. So the differences: on-premises databases, or DBMS, database management systems, are fully controlled. It's our own responsibilities to fully manage and control it. It may have some advantage because there's physical proximity. It's going to be within the building of the business. And the less distance that data has to travel, the faster it is. But it has full of disadvantages as well, because it requires very huge investment, upfront investment. Not many companies, especially small businesses and startups, afford to invest in this kind of infrastructure. And there are huge security responsibilities as well, because you have to physically and virtually secure this. It has to be secured from cyber attacks. It has to be secured from physical attacks as well, like I mentioned. And there's scalability issue as well. Scalability means, let's say you set up your servers like this on premise as a business. You are a startup company. And let's say after you set this up, assuming that you are an e-commerce company, let's say, an e-commerce startup company, assuming that you will have maximum 10,000 users, 10,000 consumers, customers. And then after 2 or 3 months, you end up having 100,000. It's very difficult to scale this infrastructure up and expand it smoothly, because it takes time. You have to physically install the infrastructure. You have to invest in this. You may not have the required finance to do so, and you have to wait till it's physically installed and up and running, be up and running, and so on. So it's not easy to scale this up. And on the contrary, let's assume that you are expecting 10,000 users and you only ended up having 1,000 users. And the remaining capacity that was built for 10,000 users is going to be idle, which is expense. You're paying for something you're not using. So scaling up and down is very expensive in on-premise infrastructure. But if it is on the cloud, if it is a cloud database, you're paying Amazon for as much as you're using. So if you're using a server, a database system for only 10,000 users, you only pay for 10,000 users. If you're no longer using that, you don't pay anything. So this is a pay as you go pricing model, most cloud services. So it's very easy. It's fully managed by the cloud provider. You don't have to do backup. You don't have to do security, cyber security, because Amazon, if it is on Amazon AWS, or if it's on Azure, Microsoft Azure, these providers secure the system themselves. You're paying for the service, for the database system, and for security, and for everything. So they have very sophisticated security systems because any other company, smaller company, couldn't afford to build that kind of system to secure their databases. But Amazon can because they are multi-trillion-dollar companies. And this is their specialty as well.
I got a quick question in the middle.
Okay.
All right. So let's say you subscribe for 10,000 users, and unfortunately you exceed, you can, subscribe, upgrade, and you can get amount that you need. When you also downgrade, I think you're supposed to downgrade it subscription, or is that's going to be like if you didn't use it, it's going to be called down to what we call it by default. You're not going to pay for anything, or how it's going to be mitigated.
Oh, it's going to be so it's not really flat subscription rate because you only pay Amazon bills you based on how much resources you've been using for the last month, for example. So you bill if you use the server or the infrastructure on AWS for only 1,000 users. By the end of the month, Amazon is going to bill you for 1,000 users for whatever, however much amount you used the server for. If it's
So,
been up and running for 24 hours for 30 days, it's going to be expensive. But if your website only has 1,000 visitors for only 2, 3 hours a day, the billing is going to be also based on those only active hours.
so it's pretty much just like utility.
Yeah, that's utility. That's water,
Cool.
electricity, exactly. And it's very cost effective, and the security is shared and is secured by Amazon, and most importantly, it's very flexible, very scalable.
Excuse me, Avila, I'm also have a question.
Okay, go ahead.
Which one do you think is better instead of confidentiality? The term
Well, that's
confidentiality
a
and the term
very good question in terms of security. What do you guys think? We have a cloud course. Actually, we're going to discuss this in a very good detail in that course. But just for sake of discussion, which system do you think is more secure? Having your database on premise within your own buildings or on the cloud?
I
Cloud
think
must be, yeah,
Hmm?
cloud
I,
DBMS must be more secure than
How
on-premises one.
about you're giving away
On
your
premise.
data to a third party company? How would you trust Amazon itself?
so
You're
there
giving out. Hmm?
there is a rules and regulation that it should have to be obeyed. If that is bypassed, that has its own consequence. Therefore,
Yeah.
they can take care of that.
Yeah. So that's very true because there's something called SLA, Service Level Agreement, not only for the confidentiality and security of the data, also how uh, how readily available the data is. There's no downtime. AWS guarantees 99.999999 SLA. So these nines are not random. You can actually sue Amazon if you don't have that level of availability. So they promise the system is going to be up and running and everything is readily available 99.999% of the time. Yeah.
So on this thing, I got a question again. If it is 99.9%, that is almost 100% running.
Yeah.
But running, does it secure your data? So the question is about security.
It has also a SLA about security as well. There is
Okay.
a promise security. Security is actually more important than availability.
Yep.
Also, they also promise that, but this confidentiality and security thing could be subjective when it comes to national level data. For example, AWS is American company, Microsoft is American, Google is American. These are the three biggest cloud providers. I don't think Chinese government would trust these companies to store Chinese government data because this is national security. So when it comes to things or data points, data sets like this on national level, maybe security is not really guaranteed because these companies can and will work with the US government and they can use your data for any purpose if you are a government. But for a given single company, there's nowhere where your data is going to be as secure as it would be in this company's hands. But that's very interesting topic right now because there are so many research papers and discussions on this specific topic. Any question? Any other question? By the way, anytime during the class, you can interrupt, you can chime in and ask questions. You don't even have to.
Yeah, can I ask you one question?
Okay.
So the XML files, so we
Mhm.
can categorize them as a key value.
X XML or Excel?
XML.
XML files are key value, semi-structured. So if you guys, the rest of you, if you don't know what this kind of files are, these are almost key value sort of structure. This kind of most websites used to be back in the days. Now it's HTML, but XML format was used to be very popular. So this is a structure, the type, and it's semi-structured. It's not fully structured because we don't know how long key value pair is going to be, how many characters, what kind of data, and so on. Whereas in structured data, in relational databases, we know exactly what kind of data we should be expecting in this column, for example, like we discussed earlier. And we can also guess or estimate as to how long this data is going to be. So this is a name, full name. There's no way it could be more than 50 characters, for example. I don't know anyone that has a name with more than 50 characters. So we can make reservations on our disk space, on our storage, and we can estimate how much space we're going to need because this is mostly easily estimatable. Estimatable, is that even a word? We can easily estimate how long it's going to, how much space it's going to occupy, and so on. So, but in the case of XML files, we know that what kind of the value pair structure is going to have, but we don't know what kind of especially how many characters and how long or how much space is going to uh, need for storage. So it's structured, but not fully structured. So it's called semi-structured data. Hope I answered your question.
Yes, you did. Thank
Welcome. Any other question? All right, so why do we use RDBMS or relational database management systems? Why? We already discussed this. Is as a data analyst, for example, especially, I mean, this is by far the most popular that you're going to be dealing with uh, at work and in whatever area you'll be going to working in. So the popularity is because most of the data that we're going to be analyzing data sets are going to be stored in this kind of databases. And there's one YouTube video, a very interesting video that narrates the history of relational database. They are one of the, I think, probably the oldest database systems types, and let's watch that and we'll come back to the lecture. History of relational databases. It's a 5-minute documentary.
If you're still typing your coding prompts, you're leaving performance on the table. You're prompting Cursor over 100 times a day, but type
IDS, IMS, and IDM. Making SOPs can definitely make you want to smash your computer. That was until I found Scribe.
Right, here's my honest review of Scribe, aka...
A database stores data, but that is not its main purpose. A cardboard box can also store data, photos,
Not this one. I think this one.
Our lives are flooded with all kinds of information. Thanks to computer databases, we interact with information easily and seamlessly on a daily basis. Databases were used to organize information long before the computer age. This Sumerian tablet is an index of medical prescriptions. Ship manifests, card catalogs, and product inventories are also databases. The computer allowed databases to be automated. Early computer databases followed a flat file model, a simple, consecutive list of records. But this format required that computers begin every search at the start of the list and search sequentially. This was a slow way to search and maintain large volumes of records. New, faster databases were needed that were expandable, reliable, and efficient. In the mid-1960s, IBM used a hierarchical model for their information management system, IMS. This tree-like structure, with parent nodes pointing to child nodes, was successfully used by NASA to manage drawings for the lunar lander. A more flexible network model was developed by GE's Charles Bachman. Now, child nodes could have multiple parents, but as the database got complicated, it was too hard to manage all those pointers. Ted Codd, a computer scientist at IBM, had a better idea. His relational database model, which he first proposed in 1970, organized a body of data into simple tables of related information. There were no pointers to maintain because tables are connected only by having matching data fields. This made it easier to access, merge, and change data. C.J. Date, an IBM instructor and author, was convinced that the relational database was a better model. Codd and Date wrote papers, lectured, and debated its merits. But Codd's relational database competed with another IBM product, the profitable IMS. So IBM was slow to support the new idea. In 1973, Michael Stonebreaker's team at UC Berkeley used Codd's idea to create the Ingress Relational Database, making it freely available for a modest fee. Several companies used it as the basis for successful commercial products. It took until 1975 for IBM to produce an experimental relational database named System R. It used a structured query language developed by IBM's Don Chamberlain and Raymond Boyce to search and modify data. A young entrepreneur named Larry Ellison was also intrigued with Codd's ideas.
Does anyone know this guy? Do you guys know this person? Anyone? You don't know? This is the second richest billionaire right now. Okay. No one knows him.
Was also intrigued.
He's one of the low-profile billionaires out there, but he's the second richest person. Larry Ellison is this guy, the person that owns Oracle. So now TikTok is owned by 80% owned by Oracle, by this guy.
With Codd's ideas. In 1977, he put up $2,000 of his own money to start a software company with Bob Miner and Ed Oates. Their mission? Develop and sell the first commercially available relational database compatible with IBM System R. Their flagship product was Oracle, which shipped in 1979. The first version ran on mini-computers, but by 1983, the company had rewritten it to run on many more computer systems, including IBM PCs and mainframes. Oracle quickly became profitable. In 1983, IBM finally released a full-fledged commercial relational database, DB2, for mainframes. But it was too late for IBM to dominate the mini-computer market, and Oracle was already selling to IBM's customers. Oracle had adopted Ted Codd's relational database concept early when his own employer, IBM, wouldn't, and Oracle became one of the largest software companies in the world. Its success helped relational databases become the way much of our computer data is organized. Working, communicating, shopping, relaxing. Nearly everywhere we go, data is gathered, organized, and made accessible. In this age of information, a database is never far away.
All right, that's a brief history of databases, specifically relational databases. That's why they're very popular right now. So what sets relational databases apart from other database types? They are table-based structure. They have very strict design, meaning if you create a table, and each column needs to have a strict definition of data types. So in relational database systems, in any of those tables, you cannot insert a number where a text is supposed to be inserted. So if this column is created as a text-based column, you cannot enter or you cannot store number. This has so many benefits and advantages why it was designed like this, because we can ensure data integrity, data validity by enforcing this kind of data type restrictions. For example, if there's a form, this is a form I gave you to fill out earlier. That doesn't really restrict anyone from providing gibberish data. For example, let me open up the link and show you what I mean. For example, here it asks for full name. I can just type my phone number if I want to. The system wouldn't tell me no. But in relational database systems, you cannot store a number where a text is expected, where a text is supposed to be stored. So they have very strict requirements, and there's very defined and clear relationships between each table in the relational database systems. That's why it's called a relational, by the way. The name relational comes from the fact that every table is related in one way or another with each other, every single table. And it has a programming language called SQL, like already discussed. All right. And the other distinction is that was not discussed here. I'll add one slide about that. Is open source versus proprietary databases. So what is open source in the sense of softwares or tools and technologies? What do you think is open source?
It's open for everyone to edit, just work on it.
Yeah, the software, the recipe, so to say, the code that was used to build the software is open. For example, we can take analogy of a physical product. For example, Coca-Cola, famously known for its secrecy, right? The Coca-Cola formula, no one really knows except for the people who have property rights or ownership of the formula. That's the opposite of open source. But when it comes to open source, if Coca-Cola was open source, you have all the formula on all the ingredients, all their portions, and everything available publicly. When it comes to softwares, that's equivalent example. So if a software is open source, then the code and the technology and everything that was used to build that software is openly available, one. And also on top of that, the software is free. Anyone can use it. But proprietary softwares are available for some fees. You have to pay a fee. You pay subscriptions or a flat fee or something to have full capabilities or full access to that software. So there are databases that are open source, and there are others that are proprietary. So let's look at them. Let's look at specifically relational databases. Relational. All right. Open source relational databases include Postgres. That's why we're using Postgres database system or this specific software, because it's open source. It's available for free for us to use. And there's another one called MySQL and MariaDB and so on. These open source relational databases are available for free. We can use them and we can even resell them. So you cannot just go around selling the softwares because no one is going to buy it from you because it's available for free. But if you want to modify it and add some interesting features to it and create something on top of this database softwares or systems, then you can commercialize it if you want. They're freely available. And in fact, if you will go over this topic in the cloud course, but there's a database called Redshift. It's a relational database software on the cloud on AWS. And Redshift was built using Postgres. So Amazon used the open source code of Postgres and they built some additional features on top of it. And they made it available for subscription. So we have to pay to use Redshift. But Amazon itself used something free to build Redshift. Okay, we can use this kind of open source softwares for free, and we can rebuild something else as well and sell it. Resell it. And there are proprietary relational database systems, among which are Oracle, the one built by Larry Ellison. So that's how Larry Ellison became the world's second richest person right now. He built a relational database management system in the early 1970s, I think. And that's proprietary. It's not for free. We have to pay. Usually companies use Oracle database and they pay millions of dollars to use this monthly. And the other is SQL Server. It's a relational database management system built by Microsoft. And it's also available for through a subscription. We have to pay fees. But most of proprietary databases, relational databases, are also available for free, but only some of their functionalities are available. So you don't have full access, but they made this softwares available, the systems available for free with limited functionalities. So for learning purpose, they're not too bad. We can learn SQL, we can learn the basic functionalities of the softwares with their limited capabilities. We don't need many advanced features to be available to learn. But for production use cases, for actual use case for companies and businesses, the free versions are not really useful. So the other category is in terms of their pricing. We have open source versus proprietary. So we've seen three ways of categorizing databases. One is based on the data they support. We have relational, non-relational, and so on and so on. And in terms of where the servers are stored. The second categorization is whether the database servers are stored physically within the company's premise versus on the cloud. And the third one is the pricing model. If it is free, it's open source. Otherwise, it's proprietary. Any question?
Yes, I have question, Abil.
Questions in the chats. Abrarao, oh, Nihat already answered founder of Oracle. Okay, I didn't see that chat line. Okay, Abrarao, free to customize. Yeah, open source, free to customize to do anything with. እንትኑ ሬሲፒው አለን ማለት ነው ኦፕን ሶርስ ማለት so MongoDB is under which database category? MongoDB is proprietary. You have to pay to use MongoDB የሚባለውን NoSQL database. It's a NoSQL database, but it's you have to pay to use it. It has free versions too. Like I said, limited capabilities, but the full features are available for fees or for subscription.
Okay, Avila, for the proprietary apps, can we reverse engine and use as open source?
That's illegal. That's basically stealing their property rights. So it's like, can you legally copy someone else's book? If I wrote a book, can you copy it and use it? No, you
No.
cannot legally do that. So there are copyright and intellectual property rights laws in every country. So reverse engineering a software and especially reverse engineering it and commercializing it, reselling it is illegal. You can get imprisoned. It's like a piracy and copying movies and music uh, contents and so on. It's illegal, technically speaking, but maybe not strictly enforced. But if you commercialize it, if you copy someone else's movie and resell it, it's illegal. It's the same with softwares.
Quick question.
Okay, Zach.
Uh, okay. If we steal someone's movie idea, will we have a penalty?
So that's like taking the inspiration or the idea and building something distinct. I don't think in the copyrights, intellectual property rights spaces, I
Because the
don't think,
companies have reserved rights to it. You cannot
but
steal their property.
you can take inspiration and make modifications to those contents in software even. For example, you cannot copy code for code Facebook and recreate exact same product. You cannot do that because Facebook has intellectual property right to this technology. But you can create your own social media platform.
Okay.
So, but you have to make enough changes to it so that it is distinct. It's not exactly same copy. You can write a song that
Yeah, but you cannot steal no one else's song idea.
yeah, you cannot do it exactly the same way, but you can just modify it and do your own.
Okay.
Yeah. Any other question?
Yeah, I got one question. Um, so the Postgres, and SQL Server, like my SQL Server management.
Mm-hmm. SQL
So
Server, yeah, you're right.
SQL Server management, like
SQL Server, just SQL Server, not management.
yeah, SQL Server. So the difference is just one of them is just open source and the other one is proprietary, and
Yeah,
their function, but in based on their function, they do the same thing.
exactly the same thing. Not only maybe they may have some differences in their interface. The software looks different. The Postgres one versus SQL Server, they have different appearances. Let me give you some analogy because I love analogies because it makes things so much easier to understand. Look at cars, vehicles. So if you have a car, is that it's Toyota, it could be Hyundai or Tesla or anything. Their functionalities are pretty much the same. Driving from point A to point B. The other features, maybe they may have fancy sound system or fancy dashboard, some other features and so on. So same with softwares like this. Postgres versus SQL Server, they serve exactly similar purposes. They support relational database, tables, and they use one language, by the way, SQL. They all use the same language, but one may have some features, some fancy functionalities that the other may not have. So there might be differences, but 99% they're the same.
Sorry, what about when it comes to the security?
Yeah, when it comes to security, that's a good question. One downside with open source softwares is there's no one dedicated body of developers that constantly updates and secures or fixes this kind of softwares because they are open source. There are developers working on it, but they are just kind volunteer software engineers that contribute to this because they're not being paid for it. But and they don't have any responsibilities. They would not be held liable if there's something wrong with the security of the software because this you don't have any agreement with them. If there's something wrong with it, then you have to accept it. You signed up for it. But when it comes to proprietary databases or any proprietary softwares, you actually have SLA, service level agreement, what's called SLAs, and they guarantee some level of security and performance in their that's like oh service level agreements. This dictates how much service and how much security and to what extent and so on that software is supposed to work for you. So proprietary softwares require this kind of agreements between you and the provider, the software vendor. So security might be much better for the proprietary databases. There might be some researches on this. Let's check open source. Open source like Postgres offers security through transparency and rapid community patching. Community patching means like there's a huge community, volunteers that contribute and update and patch or fix the softwares. There's no one responsible body. There's no company that's building or maintaining and updating the software. This community. While proprietary like Oracle or SQL Server provides security via hidden code. One, it's very hidden, so it's not vulnerable to attacks because hackers don't know the recipe or the underlying code that was used to build the softwares. So less vulnerability in this case. And vendor management, the vendor or whoever is selling with that software actively manage it. So in that sense, I would assume open source databases are a little bit less secure than their proprietary counterparts. Okay, let's see the argument here. So neither is inherently more secure. They just have different models. Okay. Open source more secure when actively managed and patched by security conscious team that leverages community strength. And proprietary software is more secure for organizations prioritizing a single point of control, vendor support, and prepackaged compliance, just but less transparent. All right, there it is. Any other question? Any other question? All right, let's get started with SQL. So, guys, if you need break, ክላሳችን 3 hour long ስለሚሆን maybe when you need or if you need like a regular break በየክላሱ 10-15 minutes, let me know. We can take a break. But otherwise, I usually just continue and finish the class without any break. Every class is 3 hour long. So today we're gonna finish in about 1 hour. In about 1 hour. So it might be boring when the class is mainly me speaking, you guys listening. For 3 hours is boring, I know, but as we go deep dive, it's going to be more practicing. So you're going to be writing codes, you're going to be working on different problems and so on. So it's going to be more engaging and interactive.
It'd be nice if you have like about 15 minutes in between a break, kind of just stretching
Yeah.
out.
Yeah, we can do that right now. Let's come back at 10:10. It's 10 now. It's 10:01.
That sounds good.
Let's come back at 10:10.
Okay.
Let me pause the Okay, we're back. Let's resume the class. So I'm not going to bore you with the theoretical parts and for whole 3 hours. So maybe Kambala 25 to 30 minutes is going to be enough. So quick recap. What exactly is SQL and what is it used for? ከእናንተ እስቲ ለምንድን ነው SQL የምንጠቀምበት? What kind of language is it? Anyone?
Well, as we already discussed earlier, it's a structural query language in which we can retrieve data and use it for multiple purposes.
You left out one important thing.
Oh, it's an electronically stored data retrieved in a database. I mean,
No, this the first definition is really good. You're right. Again, there's one important piece missing. SQL is a language. Yeah, you're right. We use it to retrieve, manage, process, analyze data. But what kind of data exactly?
Relational.
Relational, yeah. So this language only works on relational databases. It doesn't work against any other database systems. We have so many different database types. We discussed them 4 or 5, maybe up to 8 or 10 different database system types. But the SQL language only works with relational database management systems. Other types of databases have their own language. They use their own language. All right. And for this course, we're going to be using, for the first course of this program, there's another course focused on relational database management systems and SQL data analysis. We're going to use a different database system, different relational database system software, namely SQL Server. But for this one, for the first one, we're going to be using PostgreSQL. And we're using this mainly because it's free, open source. We can use full functionalities of the software for free. And it's also, I think, the second or third most popular relational database software or servers in the market. So if you learn SQL with this, chances are you're going to be encountering the same database at work, because most businesses and companies also use this open source relational database management system. And the good thing is, regardless of which kind of relational database systems you use to learn SQL, you can apply it with any relational database management system software. It's like learning how to drive. It doesn't matter if it's a Toyota or any other brand. If you know how to drive, you can drive any car, right? If you know how to use SQL, you can work on any relational database management system. The softwares are built by companies, different companies, but the whole concept is they're all relational and they all use one language, which is SQL. So we'll be using this, and some of the big companies, prominent brands, that use Postgres as their production databases include Spotify, which is very huge music and streaming service. You can imagine how much data they're able to store in Postgres. Even Apple uses Postgres. Instagram uses Postgres for its backend, the storage system. So now we're going to go ahead and install this software, this database server on our machines. So what kind of database is Postgres in terms of on-prem versus cloud? Is it a cloud database or on-prem?
It's cloud, right?
No.
Since it's up and it's going to be on-prem.
On-prem, yeah. እኛ ኮምፒውተር ላይ install አድርገን we're going to install it, download it on our local computers, on our computers. If it was a cloud, we're going to be using just browser to log into that database. And the database running on someone else's server on Amazon or Azure or whoever is our cloud provider is. But Postgres is on-prem. We have to install it on our computer or on company servers to be able to run it. But nowadays, cloud providers let you install Postgres on their cloud server, but this database was originally built for the on-premise infrastructure. Of course, it was built in 1980s or 90s. (1986). So in 1980s, there's no cloud የሚባል ቴክኖሎጂ ራሱ አልነበረም። So build ሲደረግ Postgres was built for the on-premises infrastructure, on-prem infrastructure. So locally, we download it, we install it, and configure it and use it on-premise. And this is the official site, postgres.org. I'm gonna give you the link in the chat. Since I've already installed the Postgres server, database server on my computer, I would like someone here to volunteer and share their screen so that I can walk the rest of the class through the steps of the installation. ሼር ማድረግ የሚፈልግ ካለ ዊሊንግ
I can.
Okay, go ahead.
Share screen.
All right, Alex, thank you. All right, open the link, Postgres below. Yep. Yeah, use Chrome browser. I mentioned it last time. It's always better to use Chrome. No, we can install it with this one for now. It's not a problem.
Okay. So
And your search engine, Google.
it should be
Switch it to Google for next time. But for now, it's okay.
okay.
Let's do it now, just for sake of time. Okay, download. Go to download. And your operating system is Windows. Anyone who's on a Mac, use the Mac option. And Linux, if there is one. Anyone? Use Linux. Oh, don't just scroll, guys. And የብዙ ሰው ልምድ ሁለት ነገሮች ልንገራቸው አንዴ እንደ ቴክ ፕሮፌሽናል ዋን ቲንግ እንደ ሌላ ሰው ማድረግ የሌለባችሁ ነገር የተለመደ ነገር ሌላ ሰው የሚያደርገው የሆነ ነገር ከፍቶ ቶሎ ስክሮል ማድረግ ሳያነቡ ቼክ ሳያደርጉ አንድ ሁለተኛ ደግሞ ፓፕአፕ ዊንዶዎች ሲመጡ when there are pop-up windows የሆነ ኤረር ሜሴጅ or something አፕሩቭ ማድረግ ያለባችሁ ሳያነቡ ኦኬ ኦር ካንስል ምናምን ማድረግ as a tech professional, as someone working in tech, ማድረግ የሌለባችሁ ነገሮች ሁለቱ ነገሮች don't just scroll and don't just click on things. Download የሚለውን ክሊክ አድርገው። Perfect. So we have different versions. So the latest version is 18.1. So yours is Windows. Select that. All right, here. Wait for it. It's downloading, but you can click it. Let's see the progress. Click. Yeah. Yeah, open it. Perfect. Slowly so that they can follow along. Cancel this. Oh, you have to, it's a different interface. Click run. Sorry, it's okay. Click run. Is yours, your operating system Windows 12 or what is it? 11 or 12?
11.
Okay. Open this and approve. At the bottom taskbar ላይ ያለውን ፈተውና
I don't see approve. I don't see any. Oh, here should be.
Flashing.
approve አድርገው።
Yes, right.
Yes በለው ያ wait for it. Wait for it. It's installing. Maybe if you guys have slower machines or your internet connection is weak, this may take anywhere between 10 to 15 minutes. It's okay, it's gonna take time. So those of you who have a laptop that's 8 GB RAM or less, you're going to struggle with this. Postgres consumes a lot of resources, so a lot of RAM resource especially. So ከ8 ጂቢ በታች ራም ያለው ከሆነ 8ም ራሱ you may struggle.
Hey, Abel. So I'm already just installed to get to the point where builder, Slack builder. Which one are you gonna pick?
So only uncheck stack builder. Keep everything checked and uncheck that box. Stack builder.
This version didn't have that. The only thing that it has is like, please select the application you would like to install. And among these are...
You can stop sharing, Alex.
Yes, see, okay.
Have Cafe share his screen and don't come back to you.
Okay. Okay.
Okay. What is the installation?
You see it now?
No, you gotta come back.
Because I got
I think
4 windows.
Alpha 1. Go back.
Yeah.
Back.
All right.
Back. No, I think close this down and open the installation page again.
All right.
Postgres. Yeah. Yeah, so here stack builder የሚለውን uncheck አድርገው ስልክ ቅድም አላረከውም ማለት ነው።
Yeah.
Uncheck this.
No, it's not active.
It should be.
I'm clicking on it. It's still grayed out, as you can see it.
Select the point. It says select up there. I don't know why it's not.
As you can see, I'm just
Can
clicking.
you give me control? Let me request control.
Okay.
Did you approve? Okay.
Yep.
Okay. It's someone says it's active in mine. Oh, okay. Let go of the mouse. ይዘኸው ከሆነ ልቀቀው። እኔ ስለ
Okay,
control
go ahead.
Yeah. Oh, I cannot do anything. እየሰራልኝ አይደለም።
Oh, really?
Back የሚለውን ክሊክ አድርጎስ
Yeah, because all right.
ልቆይ እኔ control አድርገው። Oh no, I'm not able to.
What you're gonna do in the bottom, as you can see down here, it's got a multiple window open. That is gonna be on the desktop for.
Okay, you have multiple desktops? Okay,
Yeah, it's got a multiple desktop on it.
Okay. So I think ይኸኛውን እዚህ ፊት ለፊት የሚታየውን ነው እንትን እያልንበት ያለ ነው። ስለዚህ I don't think
access የምታደርገው. Yeah. Let me go back to desktop one and go ahead and start up.
Is it a separate monitor or completely different computer?
It's the same. It's a one monitor, but you can multiply it up to 10, more than 10.
Okay,
desktops.
it's same processor, right?
Yeah, it's the same processor. It's 32 gigabytes.
Okay.
Mm.
Why don't you open it from the taskbar? There is a file explorer down there.
Oh yeah, you know what?
So I use the same path for.
Yeah, ጠብቁን አንድ ላይ እናድርገው።
Okay, sure. Okay, yeah,
I'll
yeah.
walk you through this.
Okay, you want to take it over or you want me to
Yeah,
drive?
go ahead. Go ahead. ሞክረው እስኪ. Let's try.
Still not.
I mean, if it's not letting you
You know
uncheck
what? I'm
this.
going to go ahead and finish it up with the others. That way I can uninstall and then
Yeah, no
reinstall
problem.
it.
No problem. We can keep this stack builder. It's just that I want you to uncheck it because we don't need it, but not going to be a problem if you just install it with everything. Just continue. Next. Click next.
Right. There we go.
Next on.
So an existing data directory has been found in seed program. So this directory and configuration will be used for installation.
Yeah, go ahead. Next again. Okay, it's installing.
It's
Please ensure
ensure.
the pgadmin server is shut down before. You already opened pgadmin?
Nope. As far as I know.
Click OK.
All right, let me go back.
Okay, it's installing.
I think it's root default password ማን ነው እየጠየቀ ያለው? ሩት መሰለኝ።
What's that?
In the chat box, someone is asking you
Okay,
default password.
chat. Let me check. ከእኛ ቀድማችሁ ካላችሁ ጠብቁ። ኔክስት ያለውን ስቴፕ አብረን እንድንሰራ። Let me check the chat. Where is it?
Do you want me to open it?
No, just keep it open.
Okay.
ያ ፓስወርዱ ላይ ከደረሳችሁ ቀላል ነገር ስጡት። ምክንያቱም የሆነ ለፕራክቲስ የምንጠቀምበት ዴታቤዝ ነው። ምንም ፕራይቬት የሆነ ነገር ሴኪር የሆነ ነገር የምናስቀምጥበት አይደለም። የምታስታውሱትን ከጠፋባችሁ መልሶ ሪከቨር ለማድረግ ከባድ ነው። የፖስትግሬስ ላይ ፓስወርድን ሪሴት ለማድረግ ያስቸግራል። ፖርት ነምበር ከጠየቃችሁ ፖርት ነምበር 5432 ከሆነ ዲፎልቱ አይ ቲንክ 5432 መሰለኝ። እሱን ኪፕ አድርጉት። እሱ ካልሰራ ደግሞ ሌላ እንቀይራለን። ዋው አይም ሰርፕራይዝድ ኢትስ ቴኪንግ ዚስ ሎንግ። እንትንህ ምንድን ነው? ራሙ ምን ያክል ነው? ፕሮሰሰሩ ምን አይነት ነው?
32 ነው። ኮር i7 1 ቴራባይት።
ዋው
አቤላ አንድ ጥያቄ ልጠይቅህ፣ ግን ከዚህ ጋር አይገናኝም።
ኦኬ ምንድን ነው ያው ኢንስቶል እያደረገ ዝም ከምንል
ለዛ ብዬ ነው። ሲግናል የምታውቀው ከሆነ ቻት አፑን ማለት ነው።
ኦኬ
እና ዩስ ፖስትግረስ ነው ዴታቤዝ የሚጠቀመው
ጠቀሙት። ኦኬ አይደን ነው
እና ዲሌት ያደርጋል ወዲያው ከላክ በኋላ እና ያን እንዴት ነው ሃንድል የሚያደርጉት? ጀስት
አይ ቲንክ ሜሴጆቹ ምናምን ስቶር የሚያደርጉት ፖስትግሬስ ላይ አይሆንም። ምክንያቱም ሜሴጅ ስትራክቸር የሆነ ዴታ ስላልሆነ በሪሌሽናል ዴታቤዝ ላይ ስቶር መደረግ አይችልም። ሜይ ቢ ዴይ ዩዝ ሳምቲንግ ኤልስ ፎር አክቹዋል ሜሴጅስ። ፖስትግሬስ ላይ ስቶር የሚያደርጉት ምናልባት የዩዘር ኢንፎርሜሽን ፕሮፋይል፣ ዩዘር ኔም፣ ፓስወርድ ምናምን እዛ ላይ ስቶር ያደርጋሉ። አክቹዋል ቴክስቶች እና ፎቶ ምናምን የምንላላከውን ግን ፖስትግሬስ ላይ አይቻልም ቴክኒካሊ ስቶር ማድረግ። ኦኬ ትንሽ ነው የቀረው።
So I'm still waiting for you. Okay.
ስታክ ቢልደር የሚለውን አንቼክ አድርገው ከቻልክ እዛ ላይ ካረገልህ
Okay.
ፊኒሽ
Finish.
And now let's check. Go to your search bar, type PG admin. I'll tell you what it is.
G or PG?
G.
Okay.
PG admin 4, the first one. No. ታይፕ ስታደርጉ ወደ ላይ እያያችሁ የምጽፉትን ነገር የሚያመጣውን ኖ አድሚንስ ሳይሆን አድሚን ጀስት አድሚን።
Admin, okay. I see PG admin 4.
ያ I'm surprised it didn't ask you for password or a phone number.
Probably earlier
Relation-
I just plugged in that.
እሱን ስታስገባ አላየሁም።
No, before that because እሱን አልፌ መሰለኝ እንትን ላይ ስደርስ
መጀመሪያ
ነው
ነው የሚጠይቀው ፓስዋርድ
ሴሌክሽኑ ላይ ተይኩ መጀመሪያ ላይ።
ኦኬ
ኢንስቶል ከማድረግ ሴታፑ ከመጀመሩ
እዛ ላይ ነው የሚጠይቀው ፓስወርድ እና
ፖርት እና ፓስወርድ።
ያ
ያ ኢንስቶል ካረኩት እኔ ፕሮባብሊ 3 ዓመት ሆኖታል እኔ ኮምፒውተር ላይ።
So whenever this release ሲደረግ are you going to simply just update it without affecting it, or are you going to install? How are you going to mitigate that?
ያ አፕዴት ማድረግ ይቻላል። እኔ ግን አይ ቲንክ አፕዴት ራሱ ተከታትዬ አድርገው ማቅ አይመስለኝም። ብዙ አፕዴቱ ሴኩሪቲ ኢሹ ምናምን ፊክስ ለማድረግ ነው እና ብዙ ሲግኒፊካንት የሆነ ለውጥ የለውም አፕዴት የሚያደርጉት ላይ።
Okay. I think most of the time it's going to be for a bug fix and stuff like that, right?
Yeah. So full screen አድርገውና full screen አድርገው and click on this.
You can drive if you want. That's going to make life easy for you.
Click here.
Click where?
On
server.
ነው.
Okay, on server.
No, Zika. Yeah.
Okay.
Okay. Provided password.
All right.
Okay.
Let me change it shorter.
No, this is your password you already provided. You're not creating a password.
Oh, if that is the case.
You said you provided already.
Yeah.
There you go. So this all set already Postgres installer gunner. This is pgadmin. If you guys wondering, we install Postgres and what is pgadmin? pgadmin is the interface or the tool we use to connect to the database Postgres. So we're connecting to Postgres. As you can see here, it says PostgreSQL 18. So Postgres server is already up and running, but we're using a tool called pgadmin. And can you guess what PG stands for? Postgres.
Yes.
Postgres administrator. This is a tool that we use to administer or manage or access Postgres server.
Sorry, Abil, I
Mhm.
couldn't connect to the server. pgadmin for server could not be connected yet.
You probably had your password wrong or something. Do you want to share your screen?
Okay, sure.
Thank you, Kaffialo, for sharing your screen.
Welcome.
Okay, go ahead.
Do you get that?
No, share على رقم قانا.
Okay.
Okay,
Here.
McDonald.
So
Okay, I think this is something to do with the configuration. Install Argyle properly. አሁን ያደረግነው ስቴፕ ሁሉ ተከተለ።
ሰርቪስ ላይ ራን እያደረገ ነው ሰርቨሩ። ቼክ አድርገው እስቲ።
ኮንፊገር ነው ብለው
እስቲ ዝጋውና እንክፈተው። ኮንፊገር የሚለውን ንካው ወይ ሜቢ እና ኮንፊገሬሽኑን ቼክ ማድረግ እንችላለን። ፖርት ነምበር ኦኬ አልሰጠኸውም፣ ወይም ደግሞ
ሴሉ ነበር የተጠቀምኩት። ዲፎልቱ ነበር 54
ዲፎልቱን ነው ወይ ተይዟል። ፖርት ነምበር ማለት አፕሊኬሽኖቹ ራን ሲያደርጉ ሶርት ኦፍ ዴታው ፍሎ የሚያደርግበት ፖርት እንትን ነው። ኦልሬዲ ተይዞ ይሆናል። 5432 የዴታቤዞች ዲፎልት ፖርት ነምበር ነው። ያ ከተያዘ በሌላ አፕሊኬሽን መቀየር አለብህ።
ይሄኛው ፊክስ ልበለው ወይስ
አርገዋ በቃ ይሁን እሱ 50-50 ኦኬ ሪስታርት አድርገው። I think it's working.
Yeah.
Click servers on the left. Provide your password. There you go.
Thanks.
You're welcome. Anyone else? Installation ላይ ኢሹ ያጋጠመው ያልሰራለት?
No, Abel still, I'm waiting for you. I can proceed, right? By myself.
Who's that? Alex?
Yeah.
Okay, you want to share your screen or?
I can.
Okay, go ahead.
Yeah. Here we are.
Okay, next. And uncheck stack builder if it works, yeah. Good. Next. And provide a password. Very simple password. እኔ 1 2 3 4 5 ነው ያደረኩት። ምንም ብዙ እንትን የሚያስብል ነገር ስለሌለው። And 54
It's good, huh?
yeah, that's good.
54
Default local ማለት እንደሆነ ታውቃላችሁ? go back አንዴ go back ይሄ ምን እንደሆነ ታውቃላችሁ?
It
ለምን
is a URL? Look,
It's
URL.
language, huh? Something.
አይደለም
ዲፎልት ወይም ሎካል የራስ ሃርድ ዲስክ ወይም ሲ ድራይቭ ላይ ማለት ነው እንዴ?
ነው ምርጫ የሚሰጠን እኮ እነዚህ ምንድን ናቸው?
Looks like timing or language. I don't know. Zurba, Nigeria. Looks like Yiddish.
የቦታ ሀገሮች ናቸው። በእርግጥ ግን ዲፎልት ካረጋችሁት ምንድን ነው የሚያደርገው መሰላችሁ? ዴታቤዛችን ስቶር የሚያደርገው ኢት ስቶርስ ታይም ሪሌትድ ነገር ታይም ዞን ከረንሲም ከሆነ ለምሳሌ አሜሪካ ከሆናችሁ በዶላር ስቶር ያደርገዋል። ሎካል ዲፎልት ካረጋችሁት ባላችሁበት ሎኬሽን ታይም ፎርማቱን፣ ከረንሲውን፣ ላንጉጁን ምናምን ሰውን ባላችሁበት አካባቢ ፎርማት እና ኮንቬንሽናል አጠቃቀም ያደርገዋል ማለት ነው። ዩሮፕ ቢሆን ይህን ሴታፕ ያደረጋችሁት የሆነ ገንዘብ አማውንት ስታስገቡ በዩሮስ ያደርገዋል። ዴት ፎርማት ኢን ዩሮፕ ኢዝ ዲፍረንት ኢትስ ዴት መንት ይር ኢን አሜሪካ ኢትስ መንት ዴት ይር መንዝ ዳይ ይር I mean so it's refers to that kind of things. Next አሁን ኔክስት አይ ቲንክ ከዚህ በኋላ ፕሪቲ ማች መጠበቅና ከጨረስክ በኋላ መክፈት ነው። ምንም ሌላ ነገር የለውም። All right, guys. We'll continue the class on Saturday. Saturday, probably we're going to have Brooke over. The session is going to walk you through some of